In this video, we're going to look at quite a range of examples, exam 1 questions relating to tangents and normals. So, firstly, we're going to look at what are the principles of tangents and normals. So, on this graph here, we have a curved line, so a purple line, which is representing a function. A tangent is a line that is a straight line that will just hit this purple line at one point. And at that point here, I call that the common point. That is a shared point. That's a point that fx and also the tangent go through. And the other important thing is that the tangent line and fx have the same gradient at that point. So that's our first point here. If I was to differentiate fx and sub in this x value a, that would give me the gradient of the purple line at x equals a. It would be the same as the gradient of the tangent, which we notation-wise sometimes call mt, gradient of the tangent. So the tangent is a straight line. Its equation is y equals mx plus c. So this gradient here is the gradient we're talking about. The normal is a line that runs perpendicular to the tangent. It runs through the same common point. So we have 3 lines now sharing one point. And what makes it perpendicular is the gradient of the normal will be -1 over the gradient of the tangent, and then vice versa, the gradient of the tangent will be -1 over the gradient of the normal. So that's these formulas here, and they are useful as well. You'll use them quite often. So some strategies for tangents and normals questions. Often you see the question and I find you're not really sure how you're going to answer it. So some strategies to use include these. You should use differentiation to help establish use differentiation to help establish what the gradient function is. If you're given the actual function, you can differentiate it to get the gradient. You should draw a graph to help you visualize what's actually going on here, if you can. So that's these 2 points. You should try and determine the coordinates of the common point. Definitely try and work out what are the coordinates of this point, or if you can't, express them in as many ways as possible. If you sub x equals a into the purple line, or the red line, or the blue line, you're going to get the same y value, and that could come in useful as well. And express the gradient in different ways. Again, using differentiation, but also using things like rise over run if you have some other information. So we're going to look at 4 different examples of tangents and normals, which kind of cover a range of strategies that you could use. This is our first example. We're told that we're dealing with the graph of y equals root x, which I've sketched. The normal to this graph has the equation y equals -4x plus a, and we're trying to find the value of a. So what I notice is, specifically, this represents the gradient of the normal. It's a normal, has this equation, and because it's written in the form y equals mx plus c, this is the gradient of the normal. So therefore, the gradient of the tangent is -1 over the gradient of the normal, which is a quarter. Having said that, that's actually not relevant for this question, but if it was a question about a tangent, you'd be able to go, well, actually, no, it is relevant. It is relevant because if we were to sketch this now, we are sketching it at a point where the gradient is equal to a quarter. So that might be, I don't know, let's say here. And we've got the normal coming through this point, and we also have the tangent, and the tangent has a gradient of a quarter. So what that means is at this point here, the gradient at this point is 1/4. So we don't really necessarily have a structure on how to solve this, but what we're going to do is try and come up with the coordinates of this point. If we can come up with the coordinates of this point, we can sub them into the equation of the normal. So the strategy is work out the coordinates of this point. At this point, the gradient is a quarter. If I now write down my equation and I differentiate it, now root x is the same as x to the half. If I differentiate this, I bring the half down and I reduce the power by 1, and this can be rewritten like this, or more simply, like this. So here's an expression for the gradient. If I let this, I'll work over here for a second, if I let this equal 1/4, I can now find the x coordinate of this point, this shared point or this common point that we're talking about. 1 over 2 root x equals 1 over 4. Therefore, 2 root x must equal 4, root x must equal 2, and x must equal 4. So we've now found the x coordinate. To find the y coordinate, I'm going to sub x equals 4 into y equals root x, which is 2. So what I know now is the coordinates of this shared point, or this common point. And I also know that this normal passes through that common point. So if I sub x equals 4 into the normal, I should get y equals 2, and then I can solve for a. So let's do that on the next page. So I've got y equals negative 4x plus a, and it passes through the point 4, 2. So if I sub this in, I can now solve for a. So it wasn't really clear what strategy I should use from the start, but I wrote down some things that I knew. I knew my gradient of my normal. I could work out my gradient of my tangent, and from there I could work out the coordinates of the common point. So if we go back to those original strategies, I used some differentiation. I drew a graph to help me visualize it. I worked out the coordinate of the common point, and I used this fact here. So I used all of these things, and really this as well. So these are some of the strategies that I used for this particular question. So let's look at the second question. So this time we've been given a graph, and we've got the equation, and the normal to this graph where it crosses the y-axis is shown. So here's my common points here. It's got an x-coordinate of 0 and a y-coordinate of something. Find the equation of this normal. Okay, so a normal is a straight line. It's written in y equals mx plus c form. So I need two things. I need its gradient and I need its y-intercept. Its y-intercept is going to be the common point. I'll find the coordinates of the common point by subbing 0 into my function, this exponential curve. So to find the y-intercept is just the same as subbing 0 into that function. F of 0 is e to the 0 and 2 plus 1. E to the 0 is 1 plus 1, which is 2. So this common point, or this shared point, is 0, 2. Now at that point, if I could work out the gradients of the tangent at that point, then I could work out the gradients of the normal, and then I'd be able to put that in here as the gradients of the normal. So at this point, how am I going to find the gradients of the tangent? I will differentiate the function. So if I differentiate this function, I bring the half down and I leave the x on 2 up there. At x equals 0, I'm going to sub in 0. E to the 0 and 2 is 1. Therefore, the gradient of the tangent here is a half. So this is gradient of tangent. The gradient of the normal is negative 1 on the gradient of the tangent, which is negative 1 times 2 on 1, which is negative 2. So therefore, the equation of the normal, its gradient is negative 2x plus 2. And that is the equation there of the normal. So again, using some differentiation there, identifying the coordinates of the common point, recognizing the normal as being a straight line, those are some of the strategies we used for that question. On to the next question, and this one's about an exponential. We're not given the actual function, but I'm told a few things. So I'm told that the tangent to this graph at a certain point passes through the point 0, 0. So I know a basic exponential curve looks like that. Plus k. Now that doesn't necessarily mean it's been shifted up. It may have been shifted down because all we're told is k is a real number. Could be positive or negative. But let's see what happens if I draw an exponential curve that looks something like this. And then let's try that again. It's a bit better. And now I have a tangent which hits this curve, let's say, but it also passes through 0, 0. So it might look something like this. This is my tangent line. So I'm drawing a graph to help me visualize this. Here's the shared points. The x coordinate is a because it's the tangent to the graph at the point where x equals a, and it passes through 0, 0. Find the value of k in terms of a. Okay, so this is really all I know. I know the equation of fx. So with this question, the approach I'm going to take is to write the gradients in two different ways. I know that the gradients at this point can be found by differentiating fx. So if fx is e to the x plus k, the derivative of that is just e to the x. And at x equals a, the derivative is e to the a. So that's an expression for the gradients of the black line at that point. Because the blue line is a straight line, I can determine its gradient using rise over run, or y2 minus y1 over x2 minus x1. I know it passes through a, and this point can be expressed as e to the a plus k. It's what I would get if I subbed x equals a into this rule, would be e to the a, whatever that x value is, plus k. So this point here, so this is quite an algebraic question in that I don't have any values. But it's still applying these concepts, but just using it algebraically, not with numbers. So another way of expressing the gradients of this line is by using y2 minus y1 over x2 minus x1. So the gradient is also this minus 0, y2 minus y1 over x2 minus x1, which ends up simplifying to this. And now what we see is that these two will be equal to one another. This is the gradient of the black line at that point, and this is the gradient of the blue line at that point, and at every point along the blue line, because it's a straight line, it has constant gradient. So now I'm going to let those two statements equal each other and find the value of k in terms of a. So I need to solve for k. So if I let these two equal each other, I'll have e to the a equals e to the a plus k over a. And now I want to get k by itself. Multiply the a over and subtract e to the a. And if you like, you could factorize it by taking e to the a out, but that wouldn't be necessary. This would be an acceptable answer here. So quite algebraic, that question. Again, not necessarily really sure how to do it at the start. We just write down some things we know, try some strategies and see what comes up. Our last question is the most difficult one because we don't really know much. We know we've got a tangent to this curve, y equals root x or x to the half plus d. We know the x value where it's a tangent, and we need to find a, c, and d. So one approach would be we've got three unknowns. We need to set up three equations. Let's draw a graph and let's see if we can visualize what's happening here. So a square root graph has this appearance to it. Plus d, it's been possibly moved up or down. We know that the tangent line has a y-intercept of -1, so the tangent line is kind of, maybe looking something like that. So let's move this square root graph down a bit, and let's draw the tangent line. Whoop. Let's just say it touches there. 9, C, -1, and we know the equation of this is this. So this is all we know at this stage. What I would do first of all would be, let's try and establish, well, the gradient of the tangent line is given as is a, so gradient of the tangent line is a because it's in the form y equals mx plus c. Let's try and establish the gradient of the black line at x equals 9. So to establish the gradient of the black line, I'm going to differentiate it, which would be this, and the same as what we did before, 1 on 2 root x. at x equals 9, gradient is 1 times 2 root 9, which is 1 on 6. So straight away, we've got a is a sixth. So now I know the equation of the blue line. The equation of the blue line is 1 on 6th x minus 1. If I sub x equals 9 into that, I will get the y value out, which is the value of c. So at x equals 9, y equals 1/6 times 9 minus 1, which is equal to, let's go on down the page a little bit. So we said, let's just scroll up a little bit and see what we had. One 6 9 minus 1, which is 9 on 6 minus 1, which is 3 on 2 minus 1, which is a half. So therefore, c is a half. So I know the coordinates of the shared points. So now I know that this shared point, or this common point, which is 9 and a half, the black line also passes through that. So if I sub x equals 9, I should get an answer of y equals a half, and then I can solve for d. So I know my black equation, or my original function, is this. If I sub in a half here, and this, then I get a half equals 3 plus d, a half minus 3, try not to make mistakes with these, negative 5 over 2. So again, I would summarise my final answer. A was 1/6, C was 1/2, and D was negative 5 on 2. So again, a case of writing down some things that you know, letting some things equal each other. Again, it's sometimes hard to see the strategy when you sit down and look at it. I just think you need to have a go at a few things and see what comes out.